This is Mastering Mathematics with your teacher, Karen Weston.
Hope you had a lovely night and I didn't keep you awake with your trying to see exactly everything that I taught you yesterday. In fact, you had the whole night, the whole of today to go through. But just to put your mind at ease, let's look at two more examples. And then I'll be taking you straight to the exam papers to show you. You have got to sit and to learn your mathematical symbols, the meaning of what your statements mean, reading your questions over again, and asking yourself, which mathematical concept should I be applying to this problem? But at the same time too, in an examination situation, remember, the only thing you have as your justification for stating what is actually in your mind is the examination paper. So you're going to make certain that you're stating those sums logically and in a sequential order. Let us look at the first example I want to bring to light today. And it is this one that says 3x is less than or equal to 5, open bracket, 9 minus x, and we are solving, okay? And not equation, the inequality, all right? The inequality. So we get our terms right. The inequality for x. And of course, we would start with a word that says since, because you're going to be taking it from your exam paper. So you're saying since 3x is less than or equal to 5, open bracket, 9 minus x, this would imply, and you can just use your arrow, put a head on it, because I see some of my students that write in this, that looks like equal. And then you're going to be ending up with nearly several equal signs in the same equation. So please don't forget to put on the head on the arrow, just because that means this implies, and you have 3x is less than or equal to, the first operation, yes, the rule of Bumdas comes into it right here. We will clear our brackets. And what do we remember? Right? The distributive law comes into it again, that everything inside the bracket must be multiplied by the scalar outside. You remember that word scalar, okay? The number outside the bracket is called the scalar, or anything that would have been outside a bracket. So it's now 5 times 9 minus, and do not forget, you have to say, I want to make this so that you see what's been done. So it's 5 times 9 minus 5 times x. And take it from me, more often than not, the mistake is made right at this juncture, because seemingly, as soon as you have said 5 times 9, you forget that you must multiply 5 times the x. Do not forget that. Speak to yourself every time, okay? And the first thing you're going to say is, I must remember to multiply everything in the bracket by the number outside. You can't go wrong, okay? So that is what that second line operation would be. And then, so we would have been getting 3x then is less than or equal to, 5 9s would give us 45, and it's minus 5x. So again, I'm going to say I am taking the negative 5 over the inequality sign. So I'll be leaving the 3 where it is. It's 3x. This comes up and it is plus 5x would be less than or equal to 45. You see, it was a negative 5x on this side. We have moved it to the other side, so we must also change our sign. And we understand, in terms of saying changing that sign, is because we would have been adding a plus 5x over here, so we have to do the same thing over here too, to add the plus 5x. Okay? I'm saying these things that you remember them. The additive identity is our 0, and the multiplicative identity is our number 1. Okay? So that is why we have these numbers here. Then we would have been getting, what are we getting here now? We are getting 3x plus 5x. This would have been giving us 8x, and it is less than or equal to 45. And x then would be less than or equal to, we have 8, but we don't want 8. So we're going to be dividing both sides by 8, 45 over 8. The 8's would cancel here, and we have x is less than or equal to 45 upon 8. We can choose to leave it as an improper fraction, or we can do a division and make it into a decimal point, a decimal number, or a mixed fraction. Now, I want to leave it here because I want to show you something. We got the answer as x is less than or equal to 45 over 8. And for the life of me, I don't know why, but students just think that they know that 5 9s are 45, so it can't be 8. So you know what they do? They just rub out the 8, put a 9, and say it should be 45 over 9. Where did that 9 come from? All right? So please do not fix the numbers to suit what you know. It is 45 over 8, not over 9. Where is this 9 coming from? So leave the people's number, okay? The answer is 45 over 8. So don't tell me, no, Miss Western, it's not 40. So all of a sudden you're going to see a pain 9. Where did that 9 come from? All right? So wrong. The answer is this, and you leave it. And that is why I just wanted to leave it as the improper fraction to show you sometimes, because this is some of the things we have to put up with students who feel that no, it should be a 9 because 5 9s are 45. So it can be 45 over 8. It is 45 over 8, and that is the answer. All right? Now, let us look at something a bit more complicated and see what we do when we have that type of inequality. So our second example, this one, where we have, and it is m over 2 plus m over 3 plus 3, and it is greater than or equal to 2 plus m over 6. Did we get all that? Yes, it's a long inequality. M over 2 plus m over 3 plus 3 is greater than or equal to 2 plus m over 6. Our first order of operation should always be to get rid of our denominator. Okay? So we will be getting rid of the denominators, and we'd look and see. So we know we have 2, we have 3, and we have 6. Generally, in getting rid of our denominators, we are finding the LCM, lowest common multiple. And it doesn't take us any big brains here to know that in terms of that we would be looking and saying the LCM would be equal to 6. If we don't know why, this is what you would be doing. You'll be putting down the denominator, 3 and 6, all right? And I'm using this method where you would go, because my teachers in the primary school, in Parham School, donkey years ago in the 1960s taught me this, and it still works for today. All right, so here we go. We'll be saying 2 into 2, that's 1. Bring down our 3. 2 into 6 goes 3 times, okay? And you go 3, and then you bring down the 1, because the aim is to make the last line empty ones, and then we know we would have accomplished our task, okay? And then so we're saying the LCM would have been equal to 2 times 3, which is equal to 6. Now I'm taking time because teachers would like to say they don't know what to do, they don't find so and so, they can't find so. It takes 2 minutes. If we're doing a sum and we're doing any problem and you realize that the students are missing in a gap in knowledge, just take what we'd be calling an aside and give it to them right at the moment. You'll be surprised to see how quickly they remember it, because it was done in association and in a context where it would have been used immediately. So don't say they don't know how to find the LCM. They don't know what you're talking about. Take a little 5 minutes and just show them immediately, and that's the matter solved. All right? So that is how we find our LCM, and you'll be surprised to see how they would go home and in their own little spare time give themselves some examples to practice. Okay, so our LCM here would be 6, and this means that for each term we will be multiplying by 6 because we want to get rid of the denominator. So that again, we'll be starting off since, because this is what we're given now. We have to copy the sum from off of the exam paper. So we're saying since m over 6 is something, then we can then say, therefore, we can have 6 times, and it is m over 2 plus, and it is 6 times m over 3 plus, and it is 6 times 3 would be greater than or equal to 6 times, and it is 2 plus 6 times m over 6. Okay, so we look and we see that each term is multiplied by the LCM. What are we going to do after that? We're just cancelling, all right? So again, it would be 2 into 2 goes 1. So let's write another line for you so that you get that example up there with the 2's and seeing how the multiplication was done and doing this. In the exam, because we would have been so very good, we wouldn't be writing so many of these steps. But when you're teaching, you go through every step so that you leave no stone unturned. And so you make certain that those students understand what you're saying. And because I want you to take your little time to understand that in giving something like this, that each term has to be multiplied by the LCM, I want you to take a minute just to absorb what is being said. Then we'll be right back.
Whenever possible, draw a diagram. Even though you may be able to visualize the situation mentally, a hand-drawn diagram will allow you to label the picture, to add auxiliary lines, and to view the situation from different perspectives. Be sure that you're working in the same units of measure when performing calculations. If a problem involves inches, feet, and yards, be sure to make the appropriate conversions so that all your values are in the same unit of measure. For example, change all values to feet.
Okay, so I hope you had a good look and we understand what we're doing. Okay, we had fractions and we had to go and find our LCM. For those of us who didn't remember or don't even know what was being spoken about in terms of the LCM, took a little time out to show you how that was done. Now, we are at the point now, having multiplied each term by the 6, we are cancelling. So it will be saying 2 into 2 goes 1, because this is also like 6 over 1, 6 over 1, 6 over 1, 6, and then that is just 6 times 2. And when you get your stuff here, you have like 6 over 1. I'm putting the 6 over 1 because I know you would have been taught that when we're doing our cancelling, it's numerator with a denominator, okay? That is how the cancelling takes place. So we have